Hi everybody, welcome back to the lecture series on reactive extensions, and this time we're going to look at a few of the Rx operators. And since observable and observer form a monad, we have all the usual higher order functions that we have seen for try, that we have seen for iterable, and that we have seen for future. And they are here also for observable of t. Flat map, map, filter, take, and so on. And in this case you see that all the operators are the same, the domain-specific ones are the same as for iterables, because observables are collections. Here, to remind you, is the marble diagram for map. A map takes a input stream, in this case an input stream of marbles, and turns each marble into a diamond. And as you see here, it doesn't really matter what this stream represents. That's the beauty of these marble diagrams. This could be an iterable or an observable, but you know, the map function behaves the same. Here is a marble diagram for flat map, and flat map for observables is subtly different than flat map for iterables. And the reason is that observable streams are asynchronous, which means that the function that you're flat mapping over your input stream will produce its values asynchronously. Now, when you have an iterable, what happens when you flat map is that you pull the first value out of the input, you apply it to the flat map function, to the function you pass into flat map, you get another stream, and that gets pulled, you know, out. And when that finishes and you pull for the next value, you pull for the next value in the outer input sequence. But with observables, you're not pulling, the sequences themselves push values at you. So the implementation has to be different. And in this case, what happens is that every time a new value arrives on the input stream, the function is called, and that one will produce the values asynchronously, and all the results will be merged into the output stream. And if you look at this example here, say that the flat map function takes a diamond, a marble, and turns that into a diamond and a square of the same color. And what you see here is that the outputs gets merged together, but the order of the individual streams is maintained. So you see, for example, there the green diamond comes before the green square, and that's always the case. So if you look at the definition of map in observable, it's really defined as a map followed by a merge. Here's another example that explains how nested streams are merged, and let's look at that. So what we start with a simple stream that has the values 3, 2, 1. Then what we do is we create an interval of the length of the number. So the first one, number 3, will send out the value 3 each 3 seconds. And then the second stream will send out the value 2, the green thing there, every 2 seconds. And then finally the blue one will be sent out every 1 second. And when you run this program, the code, by the way, will be available on the GitHub site. You will see that the output get merged, and that even though the green 3 was the first value in the input stream x's, it comes out after both the 1 and the first 2 have been emitted. All right, so this is merge. As I said, it just takes 2 streams, asynchronous streams, and whenever a value appears, it will be copied on the output. So it's in some sense a non-deterministic merge of two streams. Now, you can also use concat. That's more like how it works for iterables on observables, but it's a little bit dangerous. So let's look at why it's dangerous by taking the same example, and instead of merge, we're using concat over here. Okay, so instead of merging the resulting streams, we concatenate them. And concatenation means the same as concatenation in iterables. You wait until the stream terminates, and then you concatenate the other stream, the second stream, to the first stream. And in this case, what that means is that you have to, because we start with the red 3, which is emitted each 3 seconds, we can only start emitting the 2s and the 1s after, we have emitted the 2 3s, and we can emit the 1s after we have emitted the 2 2s. So this concat has to buffer internally, and that makes concat non-streaming. Okay, so that's why you probably should never use concat on observable streams, because it has to kind of remember the second stream until the first stream has terminated in order to concatenate it at the end. Here's the picture of concatenate, and where you see this behavior very clearly. The yellow marble there comes before the last blue marble in the first stream, but we have to delay it when we concatenate it here, because it has to come after the blue marble of the first stream. And so this is a dangerous and expensive operation. Okay, now let's look at a little bit more practical example where we're taking earthquakes. Earthquakes are the ideal example of a asynchronous data stream because they get pushed at you, and there's no way you can kind of stop them or whatever. They just come whenever they want to. And what we do here is we have a little wrapper that uses Square's retrofit to wrap the US Geological Service earthquake service. And here is the kind of code. Again, it will be available on GitHub. And what we're going to do now is we're going to do some simple queries over earthquake streams. So the first thing that we want to do is we want to find out the location and the magnitude of all major earthquakes. So in the previous example, you saw that we had an enumeration that mapped the number that you get from the geological earthquake thing into a magnitude. And here's what we do is we get our observable of quakes, then we map, and what we do is we pick out the location and we create a magnitude from this double into a magnitude value, and then we filter out all the major earthquakes, and then we just print them. Okay, so it's very, very simple. We map and filter over these asynchronous streams. Now, imagine that we have another service, the reverse geocode, where given the geo coordinate, so lat long or some other geo coordinate, and what we want to get back is a future of countries. And again, here we're using a future because when you geocode, you get one result. So we encode that using a future. And this example here shows how futures and observables can work together. So in this case, what we're going to do is we're going to start with our earthquake stream, and then we map over that. For each quake, we get a future that represents the location. And then what we do is we convert that future into an observable using the helper function observable from. So observable from takes a future and turns it into an observable. And then what we can do is we get an observable of observables, because we did a map and not a flat map. And then we have a choice whether we flatten the stream or concat it, or merge, flatten and merge are synonyms, or we concat them. So here's what happens when we flatten the streams. In this case, the earthquakes get out of sync. So the red earthquake, the geocode process might take a long time second earthquake comes in. There the geocoding takes a little time, and what we see is in the output now that the second earthquake comes before the first earthquake. And if you want to maintain the temporal order of the earthquakes, this is not a good situation. So in that case, we will have to use concat in order to make sure that the earthquakes remain in the right order. Now, as I said, this is a little bit dangerous, but in this case, since the future only returns one value, you only have to ever kind of buffer a couple of values, and assuming that things are not too slow, this should work. But in general, you might have to kind of use some form of timeout to avoid infinite buffering. All right, the last operator we're going to show is group by. So now that we have reverse geocoded our earthquakes from GPS locations into countries, we now want to group the earthquakes by country. And let's start with the merged earthquakes. And here you see it's really simple. We just say group the earthquakes by country. And what we now get is a stream that have as a key a stream of streams with a key being the country and then a stream of the country and the earthquakes. So you can do all the operations that you do on regular collections, on observable collections. So thank you so much. This was the end of the RX operators, and see you after the break.